First, I would like to thank Professor Yale Patt. Actually, he took on the student who could barely speak any English at that time. And you can hear many stories from him about me at that time as well. And then I would like to thank other HPS research group members, especially Robert Hall and Mike Bachler, who gave me a lot of input and feedback during this piece of research. Also some industry friends, Mike Charbonneau, Hunter Scales, and Mitch Elsa, for their inputs and support during early stage of this research. Actually, this piece of work was happening during the time when the problem was looking for a solution. We started this research when we were working on showing the instruction level parallelism was greater than 2 during the summer internship at Motorola 88120, led by Mike Charbonneau at that time. And first we started assuming perfect branch prediction, and we showed the instruction level parallelism was in the thousands, but then once we modeled the realistic branch predictor, given the best known method at that time, the parallelism dropped down to below 10 quickly. So we started looking for a better algorithm. And the idea of two-level adaptive branch prediction came into shape in the winter of 1990. And we published the first set of results during the industrial affiliation program called ISCA in Michigan at that time. And it just happened that a couple of Intel engineers in the audience picked up the idea and used that algorithm in their P6 design project at that time, also known as Pentium Pro, and based on many subsequent microprocessor Intel design. That's probably the reason why we are here. Last but not the least, I would like to thank all the committee members and all of you for giving me this award. Thank you.
I'd like to add two things. The first thing I want to add has absolutely nothing to do with branch prediction or the award. And that is that here we're gathered in this award ceremony. It's appropriate to mention and reflect on one member of our community who is not here today. Stamatis Vassiliadis, top inventor at IBM, took the endowed chair position at the Technical University of Delft, and he passed away in April. He was a giant in computer architecture, but more importantly, he was a human who nurtured the younger people, and I can't let the opportunity go without mentioning Stamatis. Those of you who know him understand completely that it's important that we reflect on his contributions, both as a computer architect and as a human being. So that's the first thing I want to say. The second thing I want to say is to add to what Tse-Yu said about the branch predictor and the environment at the time when we came up with the branch predictor. Because I think it's important today, because that time is here again. By that I mean that in 1990, people were claiming that IPC, upper bound on IPC was less than 2. You just can't get better than 2. It's the naysayers who put a ceiling on our creativity. And we published a paper in this conference in 1991 saying that IPC can be better than 2, and then the branch predictor came along and gave birth to a lot of research done by a lot of people that built on the two-level branch predictor. McFarlane came in with G-share shortly thereafter. Mark Evers and others came in with hybrid branch predictors. Today, our two-level branch predictor is nothing compared to the work that Cesnik, for example, is doing with the OGHL predictor. So it gave birth to an area that proved that the ceiling wasn't there. Today, we're doing the same thing. The ceiling is there. Anything worth doing has already been done. It's absolutely not the case. we're at an important place in the spectrum of computing. We're in the middle. We have problems at the top. We have process technology at the bottom. The process technology is giving us over 1 billion transistors in a chip. It's going to be 10 billion soon. Frequencies above 10 gigahertz. How do we harness that technology to keep producing better and better results? Lots of places we can work. Britton Smith's keynote in the Operating Systems and Architecture Conference Sunday morning talked about all the things, paying attention to what the operating system can do. Looking at what the algorithms need. We're already at the point where we've seen the interplay between compilers and microarchitecture. I say we've scratched the surface. And what I'd like to do is, rather than say, hey, there's a ceiling, we can't do any more, say, no, the ceiling is so far up there that, so high above us that our engineering creativity should not be hampered at all. And I encourage particularly the students in the audience to think big, take large bites, don't get caught in this trap of with 1 billion transistors, well, I'll just do multi-core with boring little tweaks of multi-core. No, there's much more out there that you can do, and I invite you to do it.